أولى ثانوي. فرصة جديدة وحلم جديد وهنعديها بالتأكيد، وهنعديها بالتأكيد. أولى ثانوي.
أهلا بيكم طلبة وطالبات الصف الأول الثانوي على قناة مدرستنا 3 تحت إشراف وزارة التربية والتعليم. Welcome my dear students. It's pleasure to work together the program of physics for the first semester for the year 2022 and 2023. Today we will start with chapter 2 and the first lesson, and inshallah it's going to be interesting, and we will study some interesting concepts and the physical terminology, and I hope it's going to be funny and useful for both of us. Let's start. At the beginning of this chapter, we will start, or you have to know before what will you study, just to be aware of what we are going to talk about. By the end of this chapter, you will be able to first differentiate between a scalar and a vector physical quantity. As you have studied in chapter 1, that we have many physical quantity in physics, and they are not have the same nature or the same time. So in this chapter, we will try to differentiate between the types or the nature of physical quantity that we'll study, not just for this semester or for this year, but for all the becoming year, inshallah. Second, you will perform scalar or dot product for a vectors or for a vectors quantities. As you know, physical quantities, it's something that it related to the experimental science, which is the physics. So, as usual, when you have any experiment or you do any activity, you have your result, and of course, you need to collect your data and make some mathematical operation on this data. So, the simplest mathematical operation that we will deal with vector is a product, which is one of the most interesting concepts in the work with vector, and you will see, inshallah. Second, perform a vector or a cross product of a vector quantities. Of course, they are not only what you will gain or what we will try to make you understand. There is a lot of concept or small skills in between, but they are the specific or the title of the concept that we will deal, inshallah, ma ba'd. Including the concept, or this is the objective, we will have some physical terminology, just like scalar quantity, vector quantity, distance, displacement, and you will know what is the difference between them, because as usual, we have taken or studied in the prior or the previous years distance. It's maybe have the same meaning of displacement, but now you are older and you will go in deep in physics just to understand the difference between displacement and the distance. Then we will take the scalar product or dot product, then a cross product or the vector product. This is for the one. First, let me ask you a question. As we said before, physics is an experimental science, which means it's based on experiments and the work in laboratory. So, during our work in lab, if I ask you, or I gave you an object, for example, this glass of water, and I told you or ask you to find the mass of this glass of water, what will you do? احنا في اللاب عادي مفيش مشكله وبنعمل اكسبيرمنت ومعانا بودي او اوبجكت محتاجين ان احنا نشوف الماس بتاعته عشان هنعمل عليه اكسبيرمنت ايا كان. And I asked you just to find the mass of this object. What will you do? Simply, you will take the object and put in on the suitable balance, whatever being the type of balance available in your lab, And all you know is just note the number that will appear on the balance. Then you will come and tell me, yes, miss, the mass of this glass or the mass of this whatever being an object is equal whatever being a number, for example, 68 grams. So the mass of this object is completely or fully defined for me just by knowing the magnitude or the value of what it contains or what appears on the balance. So we call the mass, it's just a scalar physical quantity. Scalar physical quantity, which means كمية فيزيائية قياسية. قياسية, which means it's totally or completely defined by knowing its magnitude only. انها بس مجرد بتتعرف once ان انا بعرف المقدار بتاعها قد ايه. زي الماس اوف اوبجكت، هل انا محتاج اعرف حاجه تاني غير النمبر اللي موجود عندي؟ انا قلت لك هات لي الماس اوف اوبجكت، حطيته على البالانس، قلت لي البالانس reads 68 جرام. So it's completely defined for me, just the mass equals 68 gram. So this is why we call the mass, it's considered as a scalar physical quantity. But if I told you, or if I ask you just to displace or move this glass of water, and I ask you just put it over there, you will stop just for an instant and ask me where. Where it means in which direction. So to displace this glass of water, we have many different positions with different direction. So to displace an object, or to be sure that this object made a displacement, which means it changed its position with a definite magnitude in a definite direction. ده بديهي ومنطقي، ما اقول لك حط لي كوبايه دي هناك وبعد كده هتسكت كده تقولي هناك فين؟ تمام؟ هناك فين دي which means where, which means you ask for the direction. So we call the displacement, it's a vector, a physical quantity, which means it's not defined but with the magnitude and two with the dimension. The direction of this physical quantity. Just for example, as we see here, if I ask you to find or calculate the velocity of a moving car, okay, you will ask in which moving car? I have a car, they are moved in different direction, right? Just like right moves to right or left, forward, backward, wherever. So to define the velocity of the car, you have to define the direction of motion. And this is why we call the velocity or the displacement, even the force, it's a scalar vector quantity because it's completely or definitely defined by its magnitude and to the direction. So let's start. So accordingly, physical quantities can be classified as we have explained from previous. We can scalar quantity, which is a physical quantity that can be fully defined by its magnitude and the measuring unit only. It has no direction. So the scalar physical quantity is just completely or fully defined by its magnitude or the value, and the measuring unit, of course, as you take before, there is no correct measurement process or measurement for a physical quantity without a measuring unit. So measuring unit, it's a constant. So for the scalar quantity, you have to define just only a magnitude plus measuring unit with no direction. Just like temperature, distance, and energy. Energy, it's two. It has no direction. But a vector quantity, which is a physical quantity that can be fully defined with both. We need to know both magnitude of the physical quantity, measuring unit, magnitude and measuring unit, 1 point, plus a direction of this physical quantity. Just like a force, as we said, if I ask you to push this glass or whatever being an object that you will apply the force on, you have to define or determine the amount of push force and you push in which direction. هتشوف انت مثلا هتحرك الاوبجكت ده هتزق بقوه قد ايه، تمام؟ This is the magnitude and in which direction. فين؟ يمين شمال فوق تحت وهكذا. This is just like, for example, for vector quantities, you have a force, displacement, and acceleration. Acceleration is a derived physical quantity from velocity, and we will take it in previous. The most interesting and the most clear two physical quantity, they can differentiate between scalar and vector quantity. They are distance with displacement. Distance, which means اللي هي بالعربي اللي هي المسافة، تمام؟ But displacement اللي هي الإزاحة. طب what's the difference between distance and displacement? If we see for this figure, if you just walk from the point A, if you walk from the point A to the point B, it's not necessary all the time to take the same path, the straight line from A to B. لو انت مثلا say ده الهوم بتاعك or your house and you want to go to the school at point B, it's not always a straight line. ممكن في اوقات بيبقى مثلا عايز تروح من مكان لمكان بس الشارع زحمه، في زحمه فبتضطر تاخد طريق تاني مختلف. فبالتالي ال path of motion او ال path of moving of the object, it may be curved just like this curved line upward. تمام؟ فانا بالنسبه لي ال object or the body will walk or move from point A to the point C, then to the point D until it reaches point B. We call the length of this line or the length of this path of motion, this is called a distance. And it's a scalar quantity because it has no definite direction. As you see, it's a curved up, down, upward, down, forward وهكذا. يبقى أنا بالنسبة لي distance, it'll cover the distance to reach from point A to the point B. This is the length of this path. But the straight line between the starting point of the motion till the end point of the motion, this is called a displacement. This is called a displacement. انت عملت ازاحه قد ايه؟ يعني غيرت البوزيشن بتاعك من اول ما خرجت لحد لما وصلت للبليس التاني اللي انت رايح له، عملت straight line between the 2 points بلينس قد ايه؟ تمام؟ يبقى so the distance, it's defined as the length of the path covered by a moving object from a position to another one, from the position to another position. But about the displacement, it's defined as the length of the straight line, and displacement, it's always a straight line, nothing else. It's never be curved, never be breaks, it's always a straight line. Divide the length of the straight line segment in a given direction, of course. It's not there or here or here. It's in a definite or a given direction. And where is this direction? From where to where? Of course, it's from the starting point to the end point of the motion of the object. So this line, or we will call it, it's this vector, represent the displacement that the object makes from the beginning of the motion till the end of the motion. Okay. Okay. So to differentiate or to find the difference between a distance and displacement, as we said from the beginning, distance, it's a scalar quantity, but a displacement from the beginning, it's a vector quantity. But we still have some small details or some small differences between them, just to find them, which makes us understand deeply the difference or the meaning of distance and displacement. As we said as a definition, distance is the length or the total length of the path moved by a body in a certain interval of time. Of course, when an object or when we study the motion of an object, we study it in a definite time. It's not open time, it's not random. Work in physics, it's always timed. Time, which means in a definite interval of time. So when we study or find the distance covered by a moving body, it should be in a definite interval time. فترة زمنية محددة، الموضوع مش بيبقى عشوائي. طبعا تيجي تعمل study لأي حاجة لازم بيكون في عندك constraints ماشي عليها. ومن أهمها تكون indefinite time. This is the first property of distance. It's a scalar quantity, of course, as we said before. Its magnitude depends on the path followed by the object, which means إن أنا عندي magnitude or the value of the distance covered, it depends on the length of the path. يعني إيه؟ يعني مثلا say how to say إن أنا في عندي مثلا two persons، تمام؟ two persons راحوا نفس المكان من نفس النقطة. بس أنا هقول في واحد مشي ده خد طريق مختصر، وواحد تاني أخد طريق طويل جدا. طريق مختصر أو طريق طويل ده هي دي معنى اللينس اوف ذا باس. يعني زي مثلا أنا عاوزة أجي من أول الروم هنا من مكان هنا، تمام؟ عاوزة أروح لحد السكرين، تمام؟ همشي كده. دي ديستنس مثلا سي أنا عملت ديستنس، تمام؟ أو ممكن أمشي كده ألف أراوند التيبل وبرضه هوصل فين؟ وبرضه at the same time أنا هوصل فين؟ هوصل برضه عند السكرين. So at the first point أنا عملت إيه؟ it's a small distance، مسافة صغيرة، تمام؟ لكن أنا الديستنس نفسها it depends on the path that I followed during my motion. طول المسار اللي أنا همشي فيه أو الطريق اللي أنا همشي فيه علشان أوصل للمكان اللي أنا عايزة أروحه. تمام؟ يبقى ال distance it depends on the length of the path of motion of the object. It can be more than or equal to the magnitude of the displacement. As we see in the example, it was on the screen. It's a distance, and here it's not always at the same magnitude of the displacement. تمام؟ لان احنا لو بصينا كده على الديستنس، لو جينا مثلا جبنا الخط اللي هو الكيرفد لاين ده، لو جينا فردناه وشفنا اللينس بتاعه هيكون قد ايه. تمام؟ definitely it's gonna be more than the length of the blue one، اللي هو هيكون اطول طبعا من الماجنيتيود بتاع الديسبيسمنت بتاعتي. In sometimes the distance it's equal the displacement, but it's always all the time it's بتكون more than the displacement itself. So let's come back. It's always positive. Of course it's always positive. أنا فيش حد بيمشي بيعمل مسافة يقول أنا مشيت النهاردة minus 3 kilometers. مش عارف اسمها كده. فالديستنس ده طبعا الفاليو بتاعتها أو الماجنيتيود بتاعتها it's always a positive. It's not necessary that distance will be 0 if displacement is equal 0. And we will find inshallah how to find or get that displacement. It may be 0. Displacement, the properties of displacement, it's a shortest distance between initial and the final position. It's a vector quantity, of course, as we said before. It has both magnitude and direction. Its magnitude does not depend on the path followed by the object. Its magnitude can be less or equal to the magnitude of the distance, so that it can be both positive as well as negative. And it may be equal 0 too in sometimes. This is just a simple example, just to differentiate between the distance and displacement. We have this boy moving from this position and following the arrows, following the path from A to LD. In the figure, the covered distance at photo number 1 or figure number 1, okay, and the displacement for this position, first position. And then this boy returns to the initial point, his initial point from the starting point of motion. And he needs the covered distance and the displacement. This is a simple example just for application to differentiate between distance and displacement in this pass of the boy. Find the distance with displacement at the first position, and then find the distance and displacement in the second position. At first, the boy moves as shown in the figure. The total distant cover. الديستنس عندي هنا هتيكوال ايه؟ المسارات اللي هو مشيها. عندي 3 متر 5 متر plus 3 متر. تمام؟ This at the first position. The displacement he changed at the position from the point A to the point D. ده الديسبليسمنت اللي عمله، هو غير position بتاعه من ال A لل D. So this is the displacement which is equal 5 meters. Then the boy returns to the initial point. رجع تاني مكانه from the starting point اللي هو بدأ منها الحركة. يبقى بالنسبة لي هنا ال distance equal the length of the total path covered by the boy. So which is equal 3 plus 5 plus 3 plus another 5 meters to the other side. What about displacement? Displacement, as we defined, it is the straight line or the length of the segment straight line from the initial point or the starting point of motion to the end point. He returns back again to the starting point. So there is no distance between, or there is no straight line between the initial point and the final point, so the displacement here is equal 0. I hope it's useful just for today, and let's have a summarize for our session for today on the live board. Dear students, this is a summary of episode 2, chapter 2. We talked about explain the physical quantity, and we said it divided in scalar and a vector. Scalar, just we have taken just example just like distance or temperature and time. The vector physical quantity we said or mentioned it's maybe velocity or a force or a displacement. And we said that there is a difference between distance and a displacement. As we said, if we have a starting point of motion, which is called A, and the ending point of motion, which is B, the length of the straight line between initial point and the final point, this is called a displacement. But the length of path you follow to reach a point A, to reach the point B from the point A, the length of this path is called a distance. And there is a difference between them. It's not essential, or it's not necessary to have the same magnitude or the same value. And we said and mentioned this displacement, it's always, but it's maybe in sometimes equal, but it's always less than the magnitude of the distance if the motion is not in a straight line. And we said vector physical quantity, they are represented by vectors, and the vector is denoted by an arrow just like this. We call this vector A. This vector A represented by arrow. The length of this segment line, it's proportional to the value or the magnitude of the vector itself, and the direction is represented as the direction of the effect of this of the vector that we have. So we said we may have equal vectors if we have two conditions, if they have the same magnitude and apply in the same direction. In this case, we can say vector A equal the vector B. But if we have just like this, we have a vector A, and we have over here a vector B. A vector A, it doesn't equal a vector B because they don't have the same magnitude, neither the same direction. As we said, the vectors, they are used to represent a physical quantity. That means we can make or apply some mathematical operation, just like addition, subtraction, or production. If we have two vectors, just like a vector A, apply in this direction, and vector B, apply in this direction. So this is a vector represent a summation of A plus a vector B. And we have a special case if we have two vectors applying just like forces applying on an object in two perpendicular. We can say it F1 and this is F2, apply in Y direction, and F1 apply in the X direction. We said that the resultant, it's going to be a vector between them, which is called Ft. And by applying Pythagorean theory, we can find the magnitude of the total or the resultant force or resultant vector, which is equal root square Fx square plus Lfy square. And we said the vector, it's needs magnitude and direction. We find the magnitude and we have to find the direction, which is represented by an angle theta, which is the angle between the resultant force or the vector with the positive direction of the x-axis. We can find it by tan minus 1 L theta here equal tan minus 1 the magnitude of the f on the y-axis with magnitude of the f of value of f on the x-axis. And this is a summary of what we have taken today. I hope it's easier and useful for you. Thanks for your attention and being with me. And I wish you a good day. I'll see you next time, inshallah. Bye-bye. Okay, and my dear student, this is the end of the lesson for today. I hope it's useful and it's interesting for you as it was for me. Thank you. I'll see you in the next episode, inshallah.
أولى ثانوي فرصة جديدة وحلم جديد وهنعديها بالتأكيد وهنعديها بالتأكيد أولى ثانوي